person with a weight of 625 newtons is posing for a selfie on a sloping path that is inclined at 8-degree angle above the horizontal. What is the normal force on this person? So let me draw a quick sketch of this situation. If I draw here, this is an incline. I'm just going to put kind of a stick figure type of person here on this incline. That was meant to be their two legs. I guess they're posing for the selfie here, right? So there's this person posing. And if we were to draw the FBD, even though in reality there'd be forces on both feet, we're going to ignore that fact. We're just going to simplify that into one force. We know the weight force, gravity, points down, but the normal force, following the established rules for normal forces, must point at an angle. In this case, presumably they're not doing this on a really slick surface. It wouldn't sound safe if they did. So I'm going to assume that there is some amount of friction force here that is preventing them from sliding down the hill. Now, the information we're given there of 625 newtons, that really corresponds to this weight force. So I'm going to label that as 625 newtons. I could go and solve for their mass if I wanted to based on that, right? Based on the fact that this is equal to mg, but I don't know if I need to do that for this situation. I identify this situation as a net force is equal to 0 type of situation. In other words, the sum of all these forces must be equal to 0. And so that means as a vector equation, we could say something like this is true. But that really means the way that I can interpret that and manipulate things with vectors is I could take a geometric approach to this problem and move these vectors around so that maybe I get some kind of right triangle or something. So I'll start with the gravity force. Maybe I'll make it a little bit bigger so I can get a nice sizable picture here. So this is my kind of enlarged copy of the gravitational force, and then we have the friction force is kind of going up at an angle like this. I'm going to enlarge that a little bit too. And then we also have the normal force that is at right angles to that and should, if everything works out, meet up back with the tail of the gravitational force. So again, this is my interpretation of this picture. And I know that this should form a triangle, even though, I mean, I had to sketch this and it's tricky to get everything correct, but I know based on the concept that the net force must be equal to 0 that this must come back to some kind of closed triangle-like figure. I know that the normal force and the friction force are at right angles, so I know it's a right triangle like that. And in that sense, looking at the numbers that I'm given, I've got 625 newtons right there, and I'm asked for what the normal force is. So really, I want to know that part of the triangle there. Wouldn't it be cool if I knew one of the angles of this triangle? Well, the other piece of information I was given at the very beginning is that this incline makes an 8-degree angle with the horizontal. And a trick that I want to share, I mean, I've done one like this before where we kind of went through the geometry more carefully, but a faster trick maybe for finding this angle is to think about, like, well, what would happen if this incline were kind of like cranked down or brought back down to level? What would happen to this triangle? And I think what would happen is this normal force would adjust itself to be perfectly vertical, and that would mean that actually it would kind of like maybe squeeze a triangle down this way, and this angle here that I've identified in the triangle would be the one to get smaller. So that means that one, I think, must be the same angle. I also drew this fairly carefully to make sure that, you know, this looked like the smaller angle, but be careful, I would say, because it's really easy to draw an incline really steep where it's maybe it's actually around 45 degrees. This is obviously bigger than 8 degrees, I think. I mean, it's got to be at least 30 degrees there or close to that. But if you make the incline too steep, then it gets hard to tell like exactly which angle goes where, even if you're drawing carefully. So anyways, there's some tricks there that lets you escape the pitfall of possibly going into a lot of details on the geometry there. But anyways, what this lets me recognize, though, is that I think the result, the normal force, is going to be equal to 625 newtons times the cosine of 8 degrees. And I know it's got to be the cosine because the normal force is adjacent to the angle of 8 degrees, and 625 newtons represents the hypotenuse in this force triangle. So if I take hypotenuse times the cosine of 8, I should get the magnitude of the adjacent side, which in this case will give me something in newtons, because this triangle really represents forces rather than like actual geometry that exists in the world, like visibly. Anyways, I can go to my calculator and put these numbers in, and I get 618.9, etc. But maybe it's okay if we just round that off to 619 newtons. Oops, let me make that newton look a tiny bit worse. There it is, close enough. 619 newtons.